Welcome back to the course Design of Information Systems. Our recent topic is animation, documentation and variations for the social network model. We have been looking at the animation documentation part already, and this session is about the variations of the social network model. Let's jump to the respective point. This is the entry point. The variations for the use model, for the social network model, concern the model itself, and the variation concern also partly the shell commands. So there will be some new ideas for the model definition, and there will be some new ideas for the use of the shell in a particular way. The slides shortly repeat the complete textual use model definition, the 6 slides on which the model is defined. We will jump back to the point to these slides when necessary. I have listed here the first group of variations, and in blue you see what the variation of the model is about. The first variation is about an alternative implementation for an operation that still satisfies the given pre- and post conditions. The second variation is on a variation on a post condition. Then we will have a longer discussion on one of the central invariants. For the profiles, we have required that the usernames are unique, and we will have a longer discussion about this topic. The attribute status in the friendship class was somehow redundant because the status was present as an attribute and the status was present in form of the state machine, and we will care about this issue here. The next variation is about the multiplicity at a particular composition that we have used. Then there is a variation on the role names in the association interest. We will talk about whether we can place invariants outside the class or whether we can place them inside the class. We will have a short look at the use shell and discuss the use of variables and discuss the use of queries on the use shell. And the second group of variations concerns there was, in the original model, there is one identifier, namely the identifier subject. Subject written with a capitalized S and subject written with a small s. And this identifier was used in different ways. And I will explain a way how to avoid this sort of multiple use of the same identifier. Then we will discuss how we can replace the association class friendship by a class. And the last variation, the last point of discussion will be we have this class subject where profiles can declare to be interested in particular subjects. So, for example, Putin was interested in horses, and Merkel and May were both interested in opera. So opera horses were subjects, and we will discuss here a particular way to bring sort of order into the subject by building a tree structure there with a more general notion and a more special notion. So these are the groups of variations that we will discuss, and let's go through them one by one. This was the complete model and the class diagram. I will come back to it when it's needed. The first variation is about a variation in the implementation of an operation. We have had this operation publish. That was an operation in the, here we have the publish operation. That's an operation in the profile class, and it is the operation is used to bring into the public a certain posting. The original functioning of the operation was as follows. Basically, what the operation publish did, we have declared here a variable p for with type posting. We have created a new posting object here, and then we have manipulated the posting attribute of the newly generated posting object. We have assigned here the parameter that was delivered to the operation. Then we have inserted the a link into the association poster posting, insert self p into poster posting, and as the aim of the operation here is to return the newly constructed posting, the result. Last step here in the implementation was that the result was assigned this newly created posting object p here. Result is a predefined variable with which you describe the result of an operation that returns a value. The precondition was we can only post something here, a post text, the parameter here. It is not allowed, the parameter is not allowed to be the empty string, and the post condition was, well, after the operation has been executed, it should be true that in the collection of all posting objects, there is now a posting p such that p.posting is equal to the parameter of the operation, and the second part of the post condition was that the result is equal to this found p object here, this posting object. In blue, I have indicated another implementation for this operation. So you see the signature for both operations here are identical. And what I have changed here is the more or less the inner part. And what I'm doing here is now, well, I'm checking here whether the parameter post text is already present in the existing postings. So I'm retrieving here any posting p such that p.posting is equal to the parameter text, and if if the posting is already present, then this p here will not be equal to null, and we will directly jump to the end of the operation and return this found P here, this found posting object, if this search here was not successful, then this P is initialized with a null value. And if this search was not successful, then P is still equal to to null, and only then the new posting object is created. Only then the assignment is done, and only then the insertion of the new link takes place. So this alternative operation will not create a new posting if the posting text is already present. And this alternative operation still satisfies here the precondition and the postcondition. So the main point here is the pre- and postconditions for an operation do not force you to implement the operation in one particular way. So you have freedom under the given pre- and postconditions. You typically have freedom to do one or the other implementation for an operation. The second variation concerns also an operation contract, a pre- and postcondition. This was the postcondition in the model where we have a postcondition for the operation comment. The class profile has an operation comment, and comment can be used to state for an already existing posting a comment. So the parameter here for the operation comment is a posting, and this should be, this is a posting object, and the task of the operation here, as you see here in the soil implementation, is that a commenting object is created between the commenter and the posting that is handed over here as a parameter. And the original postcondition said the following. Well, it required that after the operation comment has been executed, there is a commenting object C, that C.comment, the attribute of the comment class, of the commenting class, is equal to the second parameter here of the operation, and there should be this connection here should have been established, namely a posting, that's the parameter here, dot commenting, that is the navigation here to commenting, includes the C, that's a collection of objects here, and so to speak, this is the arm of the link that is described here is this side here in the first line, and in the second line what is described here is self.commenting includes C. Self is the self, the operation comment sits in the operation comment sits in the profile class, and self.commenting has to be equal, or self.commenting should include the C. Sorry, I was explaining. This is now this. I was pointing to the wrong, a minute ago I was pointing to the wrong side of the association. this part of the requirement of the post condition concerns the connection between profile and commenting, and the first part concerns the connection between posting and commenting. So I was pointing a minute ago, I was pointing to the wrong side of the link here. And what is changed here in the new post condition is that this navigation here from the one side of the link and the other side of the link is now not done starting from or posting or starting from self, but the navigation is done from the C object here. Instead of these two lines, we now have that the C dot commented is equal to posting, to a posting, C dot commented is equal to a posting, and the other part is C dot commenter is equal to self. So what is expressed here with this line is now expressed with this line, and what is expressed in the first formulation of the post condition with this line is now expressed alternatively with the second line here. Okay, let us come to a rather involved subject. As you see here, there are two slides where I will talk about a single invariant. The single invariant that I'm talking about is the invariant that requires unique username. Our original formulation for this invariant was that was the following. We said, well, inside the profile class we had an invariant unique username, profile.allInstances is unique username. So you can nearly literally read this invariant. Well, we want to have unique usernames in the profile class. And there are particular collection of other formulations for this uniqueness requirement. And the first one is this one here. This requirement here with the select works as follows. Well, again, we consider all profile objects and we are doing a selection here. We are doing a selection of profile objects P such that p.username is equal to self.username. This self is a context class. Self is an object of type profile, and please be aware of the fact that this invariant will be evaluated, will be evaluated for each single profile object. And when the evaluation is done, the current considered profile object is a self object here. And so the selection that is done here is we are selecting all profiles that have the same username as the current username as a self object, namely the current profile object that we are considering. So this is a collection of profile objects, and what we are requiring here, that this collection has the size 1. There is exactly one object, namely the self object, which has exactly this username here. And with this we guarantee the uniqueness of the username. This counting here, size equals to 1, can also be done in an alternative way. Instead of using here the selection, we have sort of an very sharp existential quantifier which requires the existence of exactly one object, P, such that p.username is equal to self.username. So we are requiring here one object, and only one object should, profile object should exist, which has this username, namely the username self.username. For the next formulation, I have stated here a general law which states a relationship between select and reject. So we have this operation select, and we also have an operation, a collection operation reject. The select selects objects which have a particular property P here. The P is a property, and a property for an element E here. And this selection is identical to this, that we are doing a rejection. So here we are considering all objects and we are selecting those objects which satisfy a property, and here we are rejecting objects, elements, which do not satisfy the property. And this yields the same collection of objects. So the reject is identical to the select if we negate the predicate or the property that sits here inside the select. And if we apply this, then if we apply this general rule, then the select can be turned into a reject. And well, what I've done here is I've not written here. I could have written in here the not, but I've not written the not, but I've turned the equality into an inequality. So we are rejecting all profiles that have a different username, and then we are counting the remaining objects after we have done the reject, and the size should be the same. There's another way of doing the selection process, or of formulating the uniqueness process. And it goes as follows. We are using the universal quantification. We have here a for all. That is, so to speak, a universal quantification over all profile objects. And the universal quantification with a for all allows to use, for example, two variables. You can also use only one variable here at this position. I have used two variables. I'm considering two profile objects, P1 and P2. And whenever P1 and P2 are two different objects, this implies, for the requirement of the uniqueness, that P1 username should be different from P2 username. So when I have different objects, they should have different username. And that's the requirement for the uniqueness of the username. A general property for between select and reject was formulated over here. A general property for the implies is stated over here. You should be aware of this from theoretical computer science, practical computer science. When you have an implication, then this implication A implies B is equivalent to not B implies not A. You can always formulate an implication here equivalently in this form. And if we apply this to this formula here, then well, we achieve for this formulation here a second equivalent formulation. Well, we have to exchange the order, and we have to invert the predicates, and when we invert this here, we get P1 username equals P2 username. This implies P1 equals to P2. So all formulations, 1, 2, 3, 4, 5, 6, all 6 formulations are equivalent formulations for the requirement unique usernames here. We have some more equivalences to offer and to study. We are currently discussing the profile class and the uniqueness property of the username. We have had a similar property in the class subject, and in the class subject we had a totally different shape of constraint, which was in nature very similar. Let's first look at the technical formulation. Profile all instances, the size. I'm looking how many objects are in the profile class. And then I'm doing here a different counting. I consider again the profile all instances, so all profile objects. But I'm doing here with the dot notation an implicit collect on the username. So I'm considering the collection of all profile objects, and then I'm considering the username for each of the profile objects. And please remember, this is an implicit collect, and the collect always returns a bag, so a collection with possible duplicates. So this expression here, the first part until username, so this expression is an expression of type bag of string. And I'm explicitly converting here the bag of string into a set of string, and then I'm counting the number of strings that are in the resulting set. And the requirement here is that these two countings should coincide in order to guarantee the unique usernames. The as set operation here will remove if it is such that the username is not unique. Then the as set operation, if it is such that the username is not unique, then we will have in this bag multiple occurrences of the duplicate username. And then this counting, respectively this counting, will not be the same as that counting. So in the case there are duplicates, this counting here will give a smaller value. And in the case there are no duplicates, this equality will hold. Okay, the fact that this is an implicit collect, I have made this here explicit with the I have replaced here the dot username with the explicit collect operation. We have studied this in the part where I studied OCL collection operations. I have explained that the dot shortcut is indeed a shortcut for a collect here, and you see here the explicit formulation of the dot shortcut over here. Next operation or next alternative formulation for the invariant is a formulation where I'm taking advantage of the one collection operation in order to establish the requirement unique usernames. What I can do, well, I'm considering all profiles. And I'm requiring here there is exactly one profile P such that P.username is equal to self.username. Yeah, remember this have in mind, remember, recall, this self is the object for which the current evaluation of this invariant is done. So another formulation is here with a 1. Analogous to the rules that I've stated for select and reject, and for the rule that I've stated, the rule for the connection between select and reject, and the rule for formulating an implication equivalently. Analogously, you have an equivalence rule for the 1 here. The 1 is equivalent to an existential quantifier. So when you have a collection and you state one element such that the property P holds for the element E, this is equivalent to, well, there exists an element E1 such that the property P holds for E1, and it is the case it does not exist a second element E2 such that the property holds and the element E1 is different from E2. So the 1 is formulated here in terms of exists, not, and exists again. The 1, there is only one E with the property P, is equivalent to there exists an element E1 with a property such that the property holds, and it is the only element for which this property holds. It is not the case that there exists a second element that is different from the first one for which the property holds as well.